Assalamu alaikum and hello everyone. I welcome you all in today's webinar on considerations in design of buildings prone to blast loading. This is an important topic for building designers around the world, especially in the context of Pakistan. The resource person for today's webinar is Dr. Azmatullah. He is a civil structural engineer with a vast experience of more than 14 years in the construction industry. He has extensive expertise in building planning and design, retrofitting of deficient and blasted structures. He has supervised the conservation work of various heritage buildings. He is a specialized procurement expert. His PhD research was focused on building behavior against blast loading. Without further ado, I would like to invite Dr. Azmatullah to start his webinar.
Thank you so much, Dr. Saif, for such a brief introduction. I think there is no need to further explain this slide, so come directly to the presentation. And the sequence of the presentation which will be followed will be, I will take start from the need of the day, that why we should consider blast loading in our planning and designing. And then as it is a very special topic and it is not at university level. So at the beginning, I will give you a brief introduction to blast loading, their terminologies, type of blast and their effect on the structures. And then in the second stage, we will discuss some site design considerations for the security point of view. As explosions always remains a challenge for the humanity, and the death tolls due to explosion is much more than any other causes. And if we see the scenario of underdeveloping and developing countries like Pakistan, here you can see that we have faced four major challenges in the past 3-4 decades, and which is number one is the Soviet-Afghan War, which was in early 1980s, and then the second challenge which we have faced was 2005 earthquake. And then the third one was the war on terror after 9/11 when America invaded Afghanistan. And the fourth challenge was the pandemic of COVID-19. So if you see all these issues, so you can see that during 2005 earthquake, almost 79,000 people were died of to that earthquake. And in Soviet Afghan War, almost 30,000 people were died due to the terrorist attack. And in COVID-19 earthquake, COVID-19, almost 33,000 people were died. But you can see that due to the war of terror after 9/11, almost 86,000 people were died. So the question is that as we can see that the death toll due to this terrorism is much higher than the other causes. So the question is that whether we are giving such importance to this as well, because as you can see that if you read some literature, you can find a lot of literature on earthquakes, and at the same time you can find a lot of literature of pandemics. But when you search for blast loading and terrorism, very minimal literature you will find. So I think it is the need of the day that we should consider blast loading in our planning and our designing. So the major casualties occur due to the collapsing of the structure. For example, here we have the example of Mina Bazar Peshawar blast, in which more than 137 people were died. And similarly, in Marriott Hotel, Islamabad, in which 54 people were died. And the recent attack in Peshawar mosque, in which 100 plus people were died. And these people were mainly died because of the collapsing of the structure. These casualties are not only due to the direct impact of the shock wave, but it is due to the collapsing of the structure. So I think from this slide, it is very much clear that we should consider uh, uh, blast load effect while planning and designing our infrastructure. I told you that this is a very new topic, so it will, some terminologies will be new for all of you. So I would like to uh, give you a brief introduction to these terminologies as well. For example, we will frequently use the term aggressor, and aggressor mean an individual or organization which initiate an illegitimate attack against an asset. In other words, an aggressor mean a terrorist. At the same time, we will use another word, asset. Asset is any valuable thing, which can be a human being or it can be a non-living thing. And at the same time, we have attacked. Attacked is an effort carried out by an aggressor or a terrorist. And then blast. Blast is a chemical reactions which generate shock wave, and we will discuss this in detail as well. And there is another term, explosion, which is similar to blast. There are some other terminologies such as frangible parts. Frangibles are those parts which damage quickly after having contact with the shock wave. And this is the weak point of a structure, but it has some positive effect. And its effect is that it reduces the shock pressures. And the non-frangible is the opposite of frangible. And impulse, it is the area under the pressure time curve. And shock wave is the air wave generated by the detonation which propagate at supersonic speed. Means that in every blast will not create a shock wave. And there are some explosions which will create shock wave, and some will not create a shock wave. We will discuss this in the coming slide as well. Then standard distance. This term will be frequently used in our presentation. And the distance from the asset to the nearest point, then assuming that all security measures are in place. It means that when you install full security system, and even in that case, if an explosive material can be taken to the nearest point, that the distance between the target and that point of explosive material is called as standard distance. And there is another term, maneuvering, which is an adjustment to achieve a goal. And this is normally, this terminology is used in military languages. So you will come some other words, you will come across to this word as well, CBR, which is a chemical, biological, and radiological weapons. And this is a toxic weapon. And this is basically used in some area where aggressors cannot penetrate to some target. So they leave these fumes or such chemicals in the air. So with this weapon, they damage the target. And there is another term which will be used frequently, that is VBIED, which is a vehicle-borne improvised explosive device. And there is improvised explosive devices. The difference between these two is that in case of VBIED, the explosive material is fixed in the vehicles, whereas in IED, the explosive materials can be fixed somewhere in the building, or it can be carried out by an suicide attacker. So we have explosive material. Explosive material are device that is capable of causing an explosion under certain conditions. And to initiate an explosion, you will need some sort of intake energy in the form of heat or shock or fractions. So different type of explosive materials are available in the market, but as usual, there is it has a specific unit, and the unit of explosive material is TNT, trinitrotoluene, and this is mainly used as a unit of explosive material because of its easiness to handle, and it is a very stable material. So these materials are using worldwide as a unit of explosive material. So if someone use some other explosive material, then he has to convert the weight of any other explosive material to the equivalent TNT weight. And the conversion formula is that every explosive material has a TNT equivalent factor, and you just have to multiply those factors with the weight of a particular explosive material. For example, here we can see that these are some explosive materials, and in the third column we can see the equivalent TNT factor. For example, if you have 10 kg of RDX and you want to convert this 10 kg of RDX to TNT, so you just have to multiply 10 kg by 1.1. So it is almost 11 kg.
Abida agora Sahara da Seurane kade o pechka simra ki sidi agora murji sara kade
kindly mute your
paten da idhar lega mada gore ha video dara
hello, kindly mute your mic, Dr. Sir. Okay, thank you for muting your mic. So these are the different devices which are mostly used for the terrorist attack. For example, explosive material can be fixed in a pipe bomb, and it can be in the shape of suicide belt or suicide vest. And similarly, these different type of vehicles can also be used for such type of attacks. And this is the capacity of these vehicles. For example, a semi-trawler can carry 27,216 kg of explosive material. So you have to consider this type of explosive material while designing or planning against blast loading. So very important factor, that is scaling law, which is the ratio of standoff to the cube root of the explosive charge size as an equivalent mass of trinitrotoluene TNT, which is commonly served as the basis for determining the blast load parameter. So we will explain it later again. But the intensity of the shock wave depends upon two factors. Number one is the weight of explosive material, and the other one is the standoff distance. So these two factors has been represented by another factor, which is called the scale factor Z. For example, in this case, you can see that at the right side, an explosion of 10 kg of TNT occurred at a distance of 32 meters. And at the left side, 100 kg of TNT explosive occurred at a distance of 68.68 meters. So the scale distance Z for both of these explosive material is 15 meters per cube root of kg. So the effect of both of this type of explosion on this man will be the same. That is 15. So from here, it is very clear that as we will increase the distance by twice, the effect of blast can be reduced by 100 times. For example, if in this case, a 10 kg explosive material has been blasted at a distance of 32 meters, it has the same effect on this target if 100 kg of TNT explosive occurred at a distance of 68 meters. So the standoff distance is a very important factor, and it is the most effective factor through which we can reduce the impact of blast loading. This is the pressure time history of blast loading. For example, in this case, we can see that we have an arrival time. It is the time taken by the shock wave to reach the target. So when an explosion takes place, certain time will take by the shock wave to reach to the target. And this time is very, very less. It is almost 1 to 3 millimeters. And then you can see abrupt increase in the pressures. In other words, within no time, the pressure increases from ambient pressure to the maximum. And then a decay can be observed. And after a time lapse of TA plus T naught, which is where T naught is the total duration of positive phase of shock wave, the pressure again reduced to ambient pressure. And then due to this blast, a vacuum created in the vicinity of the explosion. So there a negative pressure is created, and the air from the near surrounding will then move toward the center of the explosive material. And that is called the negative phase of shock wave. So here we can see that the negative duration of shock wave is much higher than the positive duration of shock wave. So I think from this picture, it is very much clear. Here we can see that this is the ambient pressure, where you can see a stable houses and a tree. And after the blast, due to the positive phase of shock wave, here we can see that the trees has been tilted out toward the building, and the building has also been damaged. And when the pressure reduced to ambient pressure again, then the trees comes to its original position, but in damaged condition. And because of this negative pressure, the which is called as the suction of this blast, so you can see that the trees has been tilted to the opposite side. From this graph, you can see that two type of pressure has been shown. The red color shows the reflected pressure, and the green line shows the incident pressure. The incident pressure is basically the direct pressure generated by the blast load, whereas the reflected pressure is basically the magnified pressure of the shock wave due to the constructive interference phenomena of the shock wave. We will discuss it later in the coming slide. So as we have already discussed, that all type of explosion will not create a shock wave. So explosion can be divided into two categories. Number one is deflagration, which is the decomposition of reactive material at a rate lower than the speed of sound. And the wave produced by such type of reactions propagate with subsonic speed, mean that if in case of deflagration, the wave will propagate with the speed less than the speed of the sound. And here we can see that the increase in the pressure is with the passage of time, and no negative phase will create in case of deflagration. Whereas in case of detonation, it is the chemical reaction of explosive material which produce high intensity shock wave, and this wave will propagate with supersonic speed, almost 3 to 4 times to the speed of sound. In the picture, you can see an image of a blast in which you can see a fireball and then some transparent layer. This layer is basically the compressions of the air by the blast. And in case of blast, the pressure is very high, due to which the air in the surrounding is converted into liquid state. So here the shock wave can easily be seen. So this is basically the shock wave, and the speed of the shock wave is multi-time to that of sound. And the pressure time history of the detonation is different from that of deflagration, in which we can see abrupt increase in pressure, and at the same time we can see the negative phase duration of the shock wave. So the blast can be classified in different ways. So we will discuss this that in detail. As we have already studied that the effect of blast load is mainly depends upon two factors. That is the standoff distance, which is the distance of the explosion from the target, and the second one is the weight of explosive material, and we will then correlate these two material with another factor which is called as scale distance. In this picture we can see that the distance between the target and the explosive material is constant, and when we keep on increasing the weight of explosive material, the intensity of the shock wave increases. And in the second picture, we can see that the quantity of explosive material is constant, and the standard distance reduces. So we can see that for a constant weight of explosive material, if we reduce the standard distance, the effect of shock wave will increases. So based on the scale distance, the blast load can be classified as near field blast and far field blast. If the scale distance value, Z value, is less than or equal to 1.18, so we will categorize this blast as near field blast. And if the scale distance, Z value, is greater than 1.18, we will classify this as far field blast. In case of near field blast, the temperature effect is also very important. It means that when the scale distance reduced to 1.18, less than 1.18, the fireball will completely cover the target. So in that case, you have to consider the temperature effect in your planning and designing. And in case of far field blast, you will have to consider only the shock wave effect. In case of this type of blast, temperature effect will not be significant. So there is another type of classification, which is intentional blast or unintentional blast. And in case of intentional blast, we have the terrorist activities or some sort of war. And in case of unintentional blast, we have three causes. Number one is mishandling of explosive material, and the Beirut blast in 2020 was the worst example of mishandling of explosive material. And then we have a leakage of natural gas, and the third one is these cylinder burst. So these are the three types of explosion which we can categorize as unintentional blast. So there is another type of classification of blast, and it is on the basis of the location of the explosive material relative to the target. So in that case, blast can be internal blast or external blast. As it is evident from the name that internal blast are those blasts which take place inside the building. So that can be further classified as fully vented, partially vented, or fully confined. In case of fully vented, some of the energy converted into internal shock, and some portion of the energy will be released to the atmosphere in the form of leakages. In case of partially vented blast, some part of the energy will be released to the atmosphere. Some will take part in the creation of internal shock wave, and it will also result in creating internal gases inside the building. Whereas in case of fully confined blast, it will create shock wave, and at the same time it will create internal gases in the building. And as it is fully confined, so no energy will be released to the atmosphere. And the other classification is external blast. External blast then further divided into three categories: free air burst, and surface burst. In case of free air burst, unreflected shock wave will be generated, whereas in case of air burst, reflected shock wave will be generated in both the cases, from air burst and surface burst. As we have already studied in the previous slide, that the intensity of the reflected shock wave is almost double to that of unreflected shock wave. This is some pictorial introduction of internal blast. Here we can see that in this picture, the shock wave is confined from two sides, and the remaining two sides are open. So the pressure can be released to the atmosphere through this opening. Where in case of partially vented blast, some of the energy will retain by these walls, and some energy will be released to the atmosphere through this opening. Where in case of fully confined blast, no energy will be released to the atmosphere. So in case of external blast, as we have discussed already, that we have three types of blast. Number one is free air burst, second is air burst, and the third one is surface burst. In case of free air burst, the distance of explosive material from the target is less than the distance between the explosive material from the ground. Here we can see that the distance of explosion takes place at this point, at point W, and the shelter or the target is this one. So the distance between this point W and the target is less than the distance between the point W and the ground. So in this case, the shock wave will first hit this target, and then it will proceed to the ground. So in this case, no reflection phenomena will take place. Where in case of air burst and surface burst, the distance of explosive material from the ground is less than the distance of the explosive material from the target. In this case, the shock wave will first hit the ground and then it will proceed to the target. So two type of waves will proceed to this target. Number one is this incident phase, the lines showing the incident phase, this continuous line. And there is a reflected wave which reflects from the surface, and this dashed line shows the reflected wave. So two type of waves will proceed to the target simultaneously. So at this point, these two type of waves will meet together, the incident wave and the reflected wave. And because of this junction, a constructive interference will take place. So the magnitude of reflected shock wave is almost double to that of unreflected shock wave. So the air burst and surface burst are the worst condition, worst form of external blast. So, these are some research work. I have taken this graph from my PhD research work. Here we have carried out some real-time experiment. This is the target, and 3 pressure sensors were installed on this wall. Pressure sensor 1 was installed at the base of the wall. The pressure sensor 2 was installed at the center of the wall, and the pressure sensor 3 was installed at the top of the wall. So here we can see that maximum pressure has been recorded at the base of the wall. And then the pressure at the center of the wall is less than the base one, and minimum pressure have been recorded at by the top sensor. And the reason of this is because of constructive interference phenomena. These are some videos, and you can see the shock wave and the fire bar as well. Here you can see the shock wave. This and this video has been recorded with a very high speed cameras, and this video has been recorded at 5,000 frames per second. With normal camera, you can record a video with 25 to 30 frames per second. So you can imagine that how much speed this camera has. You can see from this picture, these are the different debris, and these are the main debris. This is another video which I have recorded with the same high-speed camera. You can see this layer, this transparent layer. This is basically the shock wave. And now this is the whitish color shows the fireball of the blast. The scale distance for this blast was 1.16. So here you can see that this fireball has completely covered the target. This was the target. So in this case, you have to consider the temperature effect of the blast as well. Here, from this video, you can see the negative phase of the blast. Here you can see that after blast, the air rush towards the
तो
center of
सारा गिरा
the
दिया होगा उसके अंदर चल बच गया कहाँ जा रहा
So this was the brief introduction of the blast loading. So we will come directly now to the designing phase. So site planning designing. The site design plays a major role in reducing the risk of terrorist attack on building. So we have to consider all the aspects of risk, for example, intentional, accidental blast, or severe attack. So some of the characteristics of the site which will affect the vulnerability of the target are location of the building, topography of the building, orientation, cluster or dispersed building, and largely the vegetation. So location can further be divided into two categories, urban site and open site. In urban sites, building lots with zero setbacks where the side perimeter is at the building face. Building lots with private yards between the perimeters and the building face. And the third one is the building lot with plazas, large open spaces that can be either private or public. Where in case of open site, in this type of locations, we have open spaces with a vehicular approach from the perimeter, singular, and this site can be single building or multiple building. Here we can see that the topographic survey is important because it determines the opportunity for internal surveillance and site parameters. And the second one is screening of internal areas from external observation. The topography may be either beneficial or detrimental with respect to the surveillance. For example, in this case, we can see that this is the uncontrolled zone, and these are the parameters of the area. The area under this line is under the control of the owners of this building. So the distance between this and the building is called standoff zone. So someone can carry a truck or a vehicles to this position. So this is basically the distance, the standoff distance. So the orientation has also a very significant effect on the designing for blast loading. So here we can see that this line shows the wind's direction. Here we can see that from the northwest, we have high speed of wind, and from the northeast side, we have low wind speed. So the natural ventilation is effective and time-tested technique in all sort of building, but this can be unfiltered outside air in major vulnerability with respect to the attack with CBR agent. So operable, in other words, openable windows may be more vulnerable to blast damage than the fixed one. So you have to consider these parameters as well while designing for blast loading. There are some other parameters which are clustered or dispersed building. In this picture, you can see. Hello?
Yes, sir.
Are you listening me?
Yeah. May I ask something about?
The question answer session will be at the end of the presentation.
Yeah, okay, fine.
Okay. So here you can see that these dark greenish color shows the high risk zone, and the light green area shows the medium risk zone, and the area with this gray color, this shows the low risk zone. By high risk zone mean that this area is the prime objective, can be a prime objective of the aggressor to be targeted. So if you accumulate the imported building at this point, so it has some merits and some demerits. For example, it is very easy to cordon off this area through fencing, and you can provide a single access through this road, but at the same time, it has some demerit. For example, if an aggressor succeeded to hit this target, so it will automatically affect the buildings in the near vicinity of this target. On the other hand, if we provide dispersed facilities, so these are the areas which have important buildings. So at the same time, it has some merits and some demerits. Its demerit is that it is very difficult to cordon off all this area. And its merit is that if an aggressor succeeded to hit this building, it will only affect this one building. So in this case, the effect of blast will be experienced by less building. So these are the different factors which will be considered while planning for blast loading. Similarly, vegetation has a positive impact on the planning as well as negative impact. And its negative impact is that it will hide this area. For example, if you have a check post at this elevated position, so this area is blocked by this tree. So it is the adverse effect of this vegetation. And if you have, if an aggressor or terrorist comes to this point, so it cannot easily hit the person inside the building. It's a positive effect. So these are the different factors which has to be considered while designing for blast loading. So what will be our design strategy? Design strategy can be further classified into 4 categories. Number 1 is defense, layer of defense, standoff distance, as we have already discussed, that it is the very important factor and very cost-effective factor while designing for blast effect. And the third one is the access control, and the last one is perimeter control. There are 2 types of codes which addressed to this security designing. The one is FEMA, Federal Emergency Management Agency, and according to these guidelines, they have categorized this defense line into three categories. First defense line, it consists of barriers usually at the property line of the sidewalk or curb line. The second layer is extend from the perimeter to the side to the exterior face of the building. And the last one is usually inside the building, and that separate the unsecured and secured area. There is another type of guideline, which is General Service Administration guideline. This guideline divide this layer into 6. Number 1 is zone 1. They use the term zone instead of layer. So that is zone 1, which is for neighborhood. Then zone 2 is the standoff perimeter. Third one is site access and parking. Zone 4 is site. Zone 5 is building envelope. And zone 6 is management and building operations. So here we can see that in case of GSA zoning, we have the neighborhood. These are the area which is not in the control of the owner of this targeted building. So then we have this property line. This is called the perimeter of the area. So this is basically, this area is under the control of the owner of this building. We have a third zone, site access. By this area, people will access this building. And the zone 4 is the site. These are the clear this area outside the building. And then we have a building envelope, and the last one is the building itself. So this building then further divided into secured and unsecured zone. So there can be different strategies. For example, in case of GSA, we have 2 types of strategies. Here we can see that all the area, all the perimeter has been restricted, and this has been declared as controlled area. Here we can see that the control point is at the outer perimeter of the area. So the car parking has been provided inside this control area. While in this case, the parking has been placed outside this area. So both have merits and demerits again. For example, in this case, we have a high standard distance as compared to this position. But at the same time, in this case, your vehicles are also secured. While in the second case, your parking is outside this safe zone, so your vehicles will not safe. So somebody can attach some magnetic bomb or some IDs or VBIEDs with your vehicles in this case. So you have to consider both these factors in your designing strategy. This is the standard distance. It is very much important factor, and this standard distance is considered to be the most effective solutions for mitigating the blast effect. Here we can see that this is the targeted area, and so the distance a car can easily comes to this point. So the distance between this vehicle and the building is almost 60 unit. So at the same time, a vehicle can come this way, and the distance is 20 unit, and another vehicle can also come to this point. So this is basically the standard distance. If you keep on increasing this distance, you will in other words, you are mitigating the effect of blast loading. So the other parameter is the access control. Here you can see that this is basically the area under considerations. We have to secure this area. So for this area, we have a control point at this position, and the rest of the boundary has been cordoned off through concrete planters or barriers or fencing. So this is basically the exclusive stand zone. In case of access control, we can divide the area into two zones. Number one is exclusive zone. This yellowish line shows the exclusive zone, and the other one is non-exclusive zone. This bluish area is the non-exclusive zone. And anyone entering to the exclusive zone must have a legitimate reason. And a non-inclusive zone may be either public right of way or any area related to public building. So this area, this bluish area, is not in the control of the owner of this building. So there is another factor, which is the perimeter security system. The perimeter security system is to prevent the unauthorized vehicles and pedestrians from entering the site, and an access control point at which vehicles and pedestrians can be screened and, if necessary, inspected before they pass through this barrier area. But some factor must have to be considered while designing this perimeter security. It does not impede the city commerce and vitality and pedestrian or vehicular mobility. It should not disturb the beautification or streetscapes of the area, and priority should be given to achieving aesthetic continuity along the street rather than considering only the security of some particular people. So here you can see the different types of control parameters have been used. For example, you can see these small type of mountains covered by this is some type of dump mud, and the purpose of this type of element is to restrict this vehicle away from this building. Here we can see that this building cannot come too close to this building, and this is to ensure the standoff distance. And at the same time, you can see these cutted trees. This is basically this is creating a hindrance to the vehicle to reach to the target. Here you can see these are the benches, and in this picture you can see that the standoff distance has been ensured by providing a water body. So these bollards, these are basically the bollards. Openly you can see this it is giving a very aesthetic look, but it has a very strong foundation. Here you can see in this picture. So these are properly designed to sustain the impact of a truck or a vehicle. So here we can see that the almost 48-inch depth has been provided. So it has been properly fixed in the earth through reinforced cement concrete, and only 30 inches is outside the building. So these are the special designs of bollards for security purpose. In this picture, you can see that if we keep on increasing the standoff distance, the cost of land plus the perimeter protection is keeps on increasing. And at the same time, after this point, this is the optimum point. If you increase the standoff distance beyond this point, the total cost of security keeps on increasing. And when you reduce the standoff distance between this point, the cost of security is again increases. So the purpose of or the objective of security design is to find out this optimum point at which have a minimum possible cost of protection. This is the whole summary of security designing and planning. Here we can see that this whole picture has been divided into 13 sections. This is section number 1, which locate the asset store on site, but outside the building. If you have some asset that has to be stored outside the building, but it should be in the surveillance of this building. The second factor is the parking. So eliminate parking beneath the building. So while designing for security point of view, you are not supposed to provide parking beneath these structures, because you have to provide sufficient standoff distance. So these are the parking areas, and there is sufficient green belt, which keeps the explosive material away from the target. The third one is the minimizing the exterior signage or other indication of asset location. So while designing for security purpose, one should not provide signage, because those signage will identify the locations of the assets or the target of the aggressors. The fourth point is the trace receptable from any building as possible. So anything such like trace that should be keep away from the building. The fifth factor is to eliminate line of approach perpendicular to the building. In this case, you can see that there is no direct access to the building perpendicular to the building. So the line of approach has been provided on either side of the building. So this has also a very important factor to be considered while designing for security point of view. The sixth one is locate the parking to obtain standard distance. As we have already discussed, that parking should be provided away from the building. And the seventh is illuminate building exterior or side where exposed assets are located. And the eighth one is minimizing vehicle access point. So these points there should be minimum access point to this building. For example, in this case, we have only these two access points, and this has to be properly controlled. The ninth one is eliminate potential hiding places near the building, provide unobstructed view around the building. So this area, this should be a clear area which can be easily visible from the building. The 10th one is side building within the view of other occupied building on the side. So if there are some other building, that should be in the view of this building, so that if there is some security personnel performing their duty on this building, so this personnel should have clear vision of the activities of this building in the near vicinity. Maximize distance from the building to the side boundary. So these are the side boundaries. If you keep on increasing the distance, you are getting more and more security. This is basically also the standard distance, because here you can see that vehicles are parked. So this is the non-exclusive zone. This zone is not in your control. So an aggressor can easily take VBIED to this position. So you have to keep this distance sufficient. The 12th one is locate the building away from natural or man-made vantage points. And the last one is secure access to power, heat plant, gas, main, water supply, and other utilities. So you have to keep all these things in your consideration. This is the end of this presentations, and now you people can ask the questions if someone has.
Thank you so much, Dr. Azmal, for such an detailed and very interesting presentation. Now we will have a question and answer session. I guess some of the participants have the questions. So if someone has question, please do ask.
Sir, Assalamu alaikum.
Sir,
Hello?
Assalamu alaikum.
I guess as there are many participants who have the questions, so please raise your hands, and then I will ask who can ask the questions. Yes, Mohammed Bilal Shah, you can ask the question, please. Mohammed Bilal Shah. No. Mohammed Salim, please.
Yes, sir. Yes, sir.
Please ask the question.
Assalamu alaikum, sir.
Wa alaikum salam.
Sir, as you define that stand-off distance is the only distance that we could minimize the blast effect. Is this the only factor that we have to consider while designing?
No. Standard distance is not the only factor through which we can minimize the effect of blast load. You can also minimize the effect of blast load by designing a robust structure. But as I mentioned in my presentation, that by providing maximum standard distance is the most cost-effective factor So there are many other factors through which you can control the effect of blast load. For example, a structure with brick masonry is very much vulnerable to blast loading. And if you think that a building can be targeted by a terrorist, so in that case, one should not provide masonry walls. Instead of masonry walls, then you have to provide properly designed RCC walls. Like in case of Peshawar attack, the casualties because of masonry walls, because masonry is very weak against the blast loading. It has very minimum out of plane shear capacity. So you can design your building through reinforcement concrete or through steel structures. And in case you have already existing building which is of masonry structure, so in that case you have to retrofit your building and re-strengthen to different techniques like carbon fiber reinforced polymers or glass fiber reinforced polymers, and there are so many ways through which you can enhance the capacity of masonry building as well against the blast loading. So standard distance is not the only factor. You can mitigate the blast load effect through other factor as well.
But sir, the explosive material shall be more
Have
than.
you got the question? The answer?
Yeah, thank you, sir. Sir, I got it. But sir, the explosive material may be more than the resisting of the building. It could be.
No, as I have mentioned that, for example, you have to classify your building while planning. For example, if you think that there is an area where you can only allow pedestrian to enter, so in that case, you must keep in mind that explosive material can be communicated to the building by the attacker. And
Sir,
as I have already shown in the table, that a
sir,
suicide attacker, yeah, are you listening me?
sorry to interrupt you, but this explosive material could be high explosive, nuclear blast, it's chemical blast, it could be IED. So how we design in such a way that we could resist the building and in respect of all these blasts?
Yeah. Can you see this slide now?
Yes, sir. This is, yeah.
Okay, these are the main weapons which can be used by the terrorist, right? Either they can use a pipe bomb or suicide belt and maximum to the semi-trawler. Are you getting me?
Yes, sir.
Yeah. Here you can see that the quantity of explosive material that each VPIED can carry has been mentioned. For example, in a suicide belt, 5 kg of explosive material can be transferred from one place to another. While in suicide vest, 9 kg of explosive material can be communicated. Are you getting me?
Yes, sir.
Okay.
But sir,
If you are designing a build, yeah, I am coming towards your point. A building, then you have to design. Then you have to decide that whether you are allowing truck to comes to that building or not. If you are allowing truck to enter to perimeter, then you have to keep maximum standard distance.
this is
Are you
inversely
listening me?
proportional. Yeah.
And if you are allowing only pedestrian, yeah, if you are providing only pedestrian inside the building, you have to keep in mind that this person can carry only 9 kg of explosive material. So my suggestion is, my recommendation and code recommends that inside the building, explosive material can be carried out either by a suitcase bomb or suicide vest. Are you getting me? Hello? Hello, are you listening me?
Yes, Dr. Asmat, I guess you have explained it pretty good, and it is also explained in the
Yes,
presentation
sir.
as well.
Sir, I'm listening.
Okay, so can we move to the next question, please?
Hello?
If the question is answered, Mohammed Salim.
Sir, I'm asking number of questions. If you may indulge me to this
As
topic,
as
I'll appreciate it. I'll
no,
appreciate it. Otherwise, you may.
can you, Mohammed Salim, can you please write down all your questions in the chat box, and we will come one by one.
Sir, okay, anyhow,
Can you
but
please, as there
I
are many other as there are many other participants as well, and we have limited time, so that's why I'm asking. You can just write down all the questions
let them ask. Let them ask. I'll ask later on.
Okay,
Let's
you please just write down in the chat box so that we can come back directly to the questions instead of you going to explain all things.
If there is nobody could have
Okay,
asked.
so the next participant,
Even if
I guess,
someone, hello, Dr. Sir.
yes,
Hello, Dr.
Muhammad
Sir.
Amir.
If someone
Muhammad
have
Amir.
many questions, then he can contact me after this presentation as well in person.
Yes, for sure. Yes, for sure. Muhammad Amir Ali Khan sir, do you have any question, please?
Yes, sir.
Yes.
Assalamualaikum, sir.
Please do ask. You can ask the question.
Sir, as you said about stand-up distance, sir, stand-up distance play a key role in minimizing the explosion, just like you said. But considering metropolitan city, every single feet area is very important and expensive. We mostly avoid providing stand-up distance in metropolitan area like Peshawar. As in 2009, the blast date came in the Mina Bazar, the whole area is very congested. So could you please give an overview regarding that? That we mostly avoid stand-up distance, like in congested area. Hello, sir. Hello.
Hello, can you hear me, Muhammad Amir sir? I guess there's some internet connection issue with Dr. Asmat. He will join back. Until then, you can just write down your question in the chat box. Until then, I guess.
Fine, sir. Fine.
Hello.
Yes, sir.
Hello, Dr. Sir. Are you listening to me?
Yes, we can hear you, Dr. Asmat.
Muhammad, I think there was some problem in the internet. Can you please repeat your question?
Sir, as you said about stand-up distance, that play a key role in minimizing the explosion. But considering metropolitan city like Peshawar, every single feet area is very important and very expensive. Just like blast came in back in 2009 in Mina Bazar, the whole area is very congested and there is almost no stand-up area is provided there. So, sir, we almost ignore the stand-up distance, just like in that area. So how we will?
Yeah. Yeah. If you see the target of the title of my slide, the title of my slide is planning and designing against blast loading. So basically, this infrastructure has been constructed without any planning, and these are not properly designed security purpose. That's why we are facing this problem. This problem is not only with the blast loading, the same problem is with earthquake loading as well, as we have so many buildings in Peshawar and even in Pakistan, which are not fulfilling the requirement of seismic code of Pakistan. So that is basically the dilemma of this area. So those has to be reconsidered and replanned. For example, if you have some area which cannot be cordoned off because of highly commercial activities or highly mobility of the peoples. And if there is a target living inside the building, inside those area, so you have to shift those targeted area from that congested area. For example, each and every person is not a target of the terrorist. For example, in case of Peshawar blast, there are so many mosques where the numbers of prayers would be much more than those who were present in the masjid of police line. Basically, but the target of those person was the police persons, the policemen. That's why he took a risk to enter to those highly secured zone. So if there is an area, as you have mentioned, so you have to shift those area away from congested places. Hope you got the answer of your question.
Okay, sir. Thank you, sir.
Thank you so much,
Sir,
Dr. Smith. Yes,
sir,
Mohammed
could I
Amir.
Sir, just like you said about scale, sir, factor multiply by sir weight. Sir, if we
Yeah.
consider a vehicle,
Yeah.
so we will multiply the equivalent TNT factor multiply by the weight of the vehicle. Sir, in
No. Yes, very important question. Weight of TNT is the weight of particular explosive. It doesn't mean to multiply the total weight of the vehicles with the TNT equivalent factor. For example, if you have a truck, the total the truck is, let's suppose, 12 ton, and those truck carry of 5 ton. So you have to multiply the weight of explosive with the equivalent factor.
okay, sir. Sir, thank you. Thanks a million, sir. Assalamu alaikum.
Okay, thank you, brother.
Okay, Muhammad Zishan, if you can ask the question. Zishan Ahmed, sir. Zishan,
Thank you, Dr. Saab.
okay.
Thank you, Dr. Smith, for such a wonderful presentation. There are two questions from my side. Kindly a bit elaborate on CBR agents I saw in the slide, if you can discuss it. And secondly, the shock wave in traffic engineering, we also know this term shock wave. So how we distinguish between the one at the blast loading and one in the traffic engineering? Kindly elaborate, please.
Thank you so much, Zishan Bhai, for asking very important questions. Basically, CBR stand for, these are the antonym of chemical, biological, and ideological weapons. Basically, different type of techniques are used by the terrorists. For example, in some cases, they use chemical as a weapon, and it sometimes they use biological factors. Like, for example, if you may have heard that it was a rumors that COVID-19 is not a pandemic, but it is basically a biological war which has been produced in a laboratory in China. So these are different type of toxic materials. Some are in liquid form, and some are in gaseous form, and even some are in solid form. So different toxic materials used by the terrorists to destroy some area. And as far as your second question is concerned about the shock wave, so as we have discussed in earlier, that a blast can be categorized in two ways. Number one is deflagration. Deflagration is also the rapid release of energy by the ignition of explosive material, but the wave produced by deflagration moves with low speed. The speed of the wave produced by deflagration reaction is less than the speed of the sound. So if a wave moves with subsonic speed, that wave will not call a shock wave. Shock wave is the special form of wave which moves with a supersonic speed. For example, in my research work, when I calculated the velocity of the shock wave produced by the detonation, it was almost 4 to 5 times to the speed of sound. So only those waves will be called as shock wave if it moves or if it propagates with the speed of sound. I hope you got the answer question.
Thank you very much. Thank you very much for the explanation.
Thank you. Mohammed Bilal Shah? Mohammed Bilal Shah.
Yes,
I guess
sir.
he has.
Sir,
Yes, please ask the question, Mohammed Bilal.
I have also read the
जी
question.
सर
of
मेरा
the
सवाल ये
what
है
are
कि
the causes
ये
of-
जो है कि ये जो
Hello? Are you listening?
सर एक्सप्लेन
Yes, please, Mohammed Bilal Shah, please ask the question.
Yes, sir. I have write down the question for you, sir. If you noted, I have already written it.
Can you
In the
please?
chat.
Okay, okay. So Mohammed Bilal Shah has a question about: is there any code of security or code to follow for explosive design, RCC related design, walls or other materials using resistance?
Yes, sir.
Yeah, yeah. It has. There are many codes in designing, and that has been made by the Americans. And if someone is interested, then I can share code with them as well.
Okay, thank you, Dr. Saab. Is there anyone else who has questions? Mohammed Salim, do you want to ask some other question as well? Mohammed Salim,
Yes, sir. Yes, sir.
do you have any other question to ask?
Sir,
Otherwise, we will.
just one question to ask, sir.
Okay, please do ask, and then we will finish our webinar.
Okay, please ask.
Thank you, sir. Sir, as you mentioned earlier, that aggressor may come, the way of
Yeah.
coming aggressor, it shall be considered as a factor affecting. Sir, are you getting my point?
Hello, Salim Khan. I think there is some problem in the internet. Can you please repeat your question?
Sir, at the beginning, you were mentioning the aggressor shall come from any way, any different route.
Yeah. Yeah.
Would it impact on the building while blasting? Or?
Aggressor is basically the terrorist.
Yes, yes.
Are you getting me?
Yes, sir. Yes, sir. I got it. Terrorist. Yeah.
Okay. Aggressor is the terrorist. So if an aggressor enter into the building, it will definitely create some disturbance, either in the form of suicide attack, or in the form of bomb, or in the form of gun. So it will definitely affect the area in a building. So if you are allowing aggressor to enter into a building, so you have that this aggressor can bring a suitcase. So if you are allowing a person to enter into the building with suitcase, so you must have to keep it in mind that in such type of in such circumstances, an aggressor can carry 19 kg of explosive material to the building. So you can see in this building that in suitcase, 23 kg explosive material. So you have to design your building to resist 23 kg of explosive material. But if you are not allowing someone to enter into the building with suitcase, then you have to design the building only for 9 kg of explosive material, because that case, you are only allowing a pedestrian to enter into the building, and a pedestrian can carry an explosive material a maximum of 9 kg. So these are the different factors with which you will play, and you will design your building according to this explosive material.
Sir, I'll ask one thing,
Yes.
that if we consider
Yeah.
all of these parameters, but if you remember
Yeah.
the Islamabad Marriott Hotel, I believe so, it is
Yeah.
2009. So it was, we could say that all the parameter has failed, because Marriott Hotel has completely demolished and collapsed, because there was an vein, I believe so, there was vein inside the hotel, and the damage was ultimate. If you remember the 2009.
Yeah. Your
In that case,
statement
sir, I would
is
say,
partially correct.
Sir, my question in that case, we have been completely
Yeah.
failed by considering all of these factors that could be affecting while designing the building.
Yeah. Your answer is partially correct. Your question is correct up to the extent that the Marriott Hotel was completely or maximum it was damaged. Up to this extent, it is correct. But as you said that all the parameters were considered, security parameters were considering while designing the security Marriott Hotel. This statement is not correct, because they have allowed the vehicle to reach to a point to the point where sufficient standard distance was not provided. If they were allowing, for example, if they were allowing small moving van to that point, so they should keep in mind that the standard distance should be sufficient to mitigate the shock generated by 4,536 kg of explosive material. So they allowed the van to enter into a zone which was not properly designed for security purpose.
But sir,
Thank you so Muhammad Salim. I will share the contact details of Dr. Azmat with you, and also the email address, so you can ask further questions later on. Thank you so much, everybody, for joining us in today's webinar. It was and thank you so much, Dr. Azmat Saab. It was a wonderful webinar, and we have learned a lot of new things, especially in the context of Pakistan related with the blast loading. I hope we will engage you also in our future webinars as well. And thank you so much, all the participants, for joining us in today's webinar.
Thank you so much, Dr. Saab, for giving me an opportunity to interact with such a wonderful audience, and I'm thanks to all of them. And inshallah, we hope that we will meet again with another topics. Thank you so much.
Inshallah. I hope to see you all in other webinars. Thank you.
Thank you, sir.